Just to review, we know what a subnet mask is. It's a comparison tool. Now, for us as humans, it's nice when we see an IP address and a subnet mask, and the subnet mask falls in a nice boundary of a byte, like 255.000 or 255.255.00. Right? That's real easy for us using our eyeballs to do that comparison and say, oh, okay, clearly this octet and this octet belong to the network. Everything else is host bits. But what I've been trying to show you with some of these quiz questions here is the subnet mask gives you the ability to draw that dividing line anywhere in that 32-bit IP address. It doesn't have to fall right at the end of a byte. So for example, in this particular case, it does fall right at the end of a byte, right? Right after the second byte, our subnet mask ends. And so it says, okay, the first 2 bytes with the /16 belong to the network. Another one where it falls right at the end. So in this case, with a /24, that says the first 3 entire bytes belong to the network. No problem. But you could easily do it like this, /28. Where you say, okay, the subnet mask extends all the way into the last octet. 4 bits of the last octet belong to the group. So in that last example, example number 3 there, we've only got 4 bits left for host. So let me ask you some questions about what you see right here. Question number 1, what was the original classful network before any subnet masks were applied? So forget about the /16, /24, and /28. If we were looking at this purely from a classful network perspective, what would the classful network have been? Go ahead and someone type that into the question feed there and answer that for me. Does anybody know what the original classful network was? Well, the original classful network was the 1 network, right? With the first bit being a 0, that was a class A. So we only looked at the first byte. The first byte, if we translate that back to decimals, the number 1. So that was the 100 network. Next question. In all 3 of these examples, what is the network address now that we've got /16, /24, and /28? So in this first example here, example number 1, given the subnet mask, we're no longer doing classful. What's the new network address based on what you see right here? Well, hopefully it's pretty easy. You just count up the red bits. The first byte is 1. The second byte is the number 3. So this is the 1.3 network. In the second example, our network address is now 1.3.192. And the third example, the network address is 1.3.192.112. That one's a little bit tougher. 112 is the 4th octet. Of these 3 examples here with these 3 different subnet masks, which one provides for the greatest quantity of hosts? Well, hopefully you very quickly said example number 1, because example number 1's got a whole lot of host bits. The other 2 examples don't have as many. Last question about this. If this company was originally given the Class A network of 1000, which of these subnet masks would provide for the greatest quantity of subnets? In other words, which of these subnet masks would allow us to take that original network of 1000 and carve it up into the most quantity of subnets that we could, give us the most variation? Well, hopefully you said example number 3. With example number 3, I can't touch my original network of 1, but with a /28, that means I've got 8, 16, 20 bits of subnetting. That gives me 2 to the power of 20 combinations I can come up with. Tens of thousands of, hundreds of thousands of networks I can come up with. So why do we subnet? So we can divide a single allocated network into multiple subnetworks. That's the whole reason behind it. Minor loss of host space available. So here's a practical example. Imagine if you lease a network from your ISP for $100 a month. The building here we see requires 4 networks. If we used classful addressing, that right there would cost us $400 a month because we had to purchase or lease 4 unique networks. With subnetting, I can take just one classful network, subnet it. I'm only paying $100 a month. I'm only paying one fee for my 20,000 from my ISP, but by extending those bits out with a subnet mask, I've now given myself 4 unique networks, but I'm only paying for one of them. One of the key points I want you to take away from this is that as I take my original network and I say, okay, I'm not going to take some of my host bits and add them to that network, give me a little bit of room to play and have variation. Well, the more host bits you steal, you'll see that term a lot, stealing bits, which means you're taking your host bits and you're stealing them for networking bits. You're converting them into subnet bits. The more subnet bits I have, there's pros and cons to that, right? The more subnet bits I have available to me, the more networks I can come up with. But the more subnet bits I have, the less host bits I have. And the fewer host bits I have, that means that each subnet can't have as many hosts anymore. The subnets are getting smaller and smaller. So here's an example of that. So I got this class B from my ISP, 180.1, that's the network. We know that those original 16 bits are untouchable. Can't touch those bits. So we ask ourselves, how many host bits do I have? Well, in this case, I've got 16. 16 bits I can play with on the back end of this address. For every host bit that you convert into a subnet bit, you've just gained 2 additional networks. 2 additional networks. For example, if this is what I was given from my service provider, let's say 1, 0, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's what I'm given from my ISP, and I can't touch that. Okay, there's my remaining 16 bits of host bits. Well, if I say, well, here's what I'm going to do. I'm going to take this bit right here and add it to my networking bits. I'm going to say, well, my group, my broadcast domain, is the first 17 bits. Well, I know I can't touch this original pattern of 16. That was purchased from my ISP. But what can I do? I can say, well, I've got one network that's 129.1 and then put a 0 right here. My only other option is to put a 1 right there. I've just now taken the one network I got from my ISP and subdivided into 2 portions. One broadcast domain is a 17-bit group number ending with 0. The other broadcast domain is a 17-bit number ending with a 1. You can see if I move it, let's say I move that line. I say, well, I'm actually going to now take 2 of my host bits. Well, now what can I have? Well, I can have one broadcast domain that ends with 00, another one that ends with 01, another one that ends with 10, another one that ends with 11. So with 2 bits, I've now just given myself 4 combinations. So what you're going to see here is this basically boils down to this nice formula. 2 to the power of subnetting, or 2 to the power of n, gives you your quantity of subnets. In other words, let's go back to my example here. I'm given this original network of 16 bits, and I say, well, I need, let's say, 8 networks. Well, if I use that formula, 2 to the power of stolen bits or 2 to the power of subnetting bits is going to be greater than or equal to the number of networks I need. So now I solve it. I say 2 to the power of Sn subnetting bits is going to be greater than or equal to 8 because I need 8 networks. So you say, oh, well, okay, that would be the number 3. If I have 2 to the power of 3, if I steal 3 bits, that will actually give me 8 combinations of numbers. 000, 001, 010, 011, all the way up to 111. 8 possible combinations. So you might get questions like that on your CCNA or even in real life. You're given some base network and you're told, okay, well, you need 15 networks or you need 30 networks. How many host bits do you need to repurpose or reconvert into subnetting bits to give you enough variation for the 15 networks you need or the 20 networks that you need? Based on that, let's do some, before we do another quiz, one other key thing here. One other key thing. Let's go back to this for a moment. In my example, I said, well, I need to have 8 networks. You say, oh, well, okay, well, 2 to the power of 3 works, but why don't I say, I don't know, why don't I steal this many? That looks good. Why don't I steal 11 bits, right? Because 2 to the power of 11 is going to give me far more than 8. Yeah, but it'll give me the 8 you need, right? Why not just use 8 networking bits, subnet bits? Well, here's the thing. Remember, the further you push this line to the right, the more bits you steal, the less host space you have available. If I put my line way out here, my broadcast domain is not going to be able to have very many laptops and PCs and printers in it, because I don't have very many addresses left for host addresses. So when you're doing subnetting in this way that we're doing right here, the idea is push your line to the right, not as far as you can go, but as minimal as you can go. In other words, you say, okay, if I push it just 1, will that be enough? It's not enough. If I push it 2 to the right, is that enough? It's not enough. Well, if I push it 3 to the right, that's just barely going to give me what I need. That's where you stop. Where the number you come up with here is just barely what you're looking for, but it just fits what you're looking for. Sure, you could keep pushing it to the right if you wanted to, but now you're sacrificing host space. So let's do some examples of this. So you are leased the following network from your ISP, the 45 network. If you convert the first 3 host bits into subnetting bits, how many total subnets will you have available? Okay, time's up. If we use our formula of 2 to the power of subnetting bits gives us our total quantity of subnets, well, if we steal 3 bits, that's 2 to the power of 3, which gives us the number 8. Robert, I see your question there. When start stealing point, is it connected to the classful network? So the question is, where do you start stealing the bits from? You have to ask yourself, okay, what was I originally given? What was I given from my service provider or from my regional internet registry? You know, of my 32-bit number that they gave me, what amount of those bits do they consider untouchable as the networking portion? Now, they may have given you a classful network, or they may not. For example, your regional internet registry or your service provider could say, okay, we're giving you this 140.55.64.0/18. So what that means is, from the service provider's perspective, I am not allowed to touch the first 18 bits. That is not a classful mask. Right? A classful network would be a /16 because 140 is a class B address. But here, the service provider is giving me a /18. So that means if I'm going to take that one network and subdivide it into subnets, I'm going to have to go beyond /18. So in this particular case, if a /18, let me ask you this. If they're giving me a /18, how many host bits do I have available from this one network that I just purchased from my service provider? How many host bits are left? I've got 14 host bits left, right? I've got 14 host bits because my service provider is saying, look, as far as we're concerned, the first 8 bits here are networking bits, the first 8 bits here are networking bits, and the first 2 bits here are networking bits. So that means of the third octet, I've got 6 host bits left. And then of the fourth octet, I've got 8 host bits left. So I've got 14 host bits available. 1, 2, 3. So what this is showing me in this particular case is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So I can't touch those. So this is what they've given me right here. So I'll just say this is untouchable. So now what's left over? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So now I'm going to start stealing from right here. If I'm going to start creating my subnets, I have to start from the right of this line. So my subnets will be a /19, /20, /21, but I can't go anything less than /18 because /18 is what they gave me. And yes, Robert, that number that you just did, this right here, I'll just put it right there. That's how you determine your host requirements. That's actually the next slide. So right now we've just been focusing in on how many bits do I need to steal to come up with the number of subnets that I need. Here's another one. You are leased this network from your service provider. If you convert the first 6 host bits into subnetting bits, how many total subnets will you have available? And if we use that same formula, 2 to the power of 6 gives me 64 subnets available. That's right, 2 to the power of 6. Now let's take it up a notch. Make it a little bit more complicated. You are leased the following network from your service provider. If you convert the first 3 host bits into subnetting bits, what will be the subnet address of the 4th subnet? All right, some of you may have been able to work this one through, some of you didn't. Let's go ahead and look at the logic behind this. Okay, so we're starting with 45. I cannot touch those first 8 bits. And we're saying I'm going to be subnetting my next 3 bits. So that gives me these various combinations. The 4th subnet, well, the first one is 000, and the next one is 001. So the 4th combination I can come up with is 011. So if I take all of my remaining host bits and convert them into zeros, I get that. And so my 4th subnet is the 45.96.00 network with a /11 mask. Start out as /8, and then I added 3 bits to it, making it into a /11. Let's do another one of these. You are leased the following network, 199.000/24. From the single network, you need to create 7 subnets. What will be your new subnet mask? And the correct answer here was 255.255.224. Why is that? Well, we need to create 7 subnets. So we know 2 to the power of our subnetting bits must be greater than or equal to 7. So if we do 2 to the power of 3, that gives us 8 subnets. So 3 is the minimum we can steal. So if we start out with a /24 and we add 3 more bits to that, that gives us a /27. /27 means all 8 bits of the first octet, all 8 bits of the second, all 8 bits of the third, and 3 bits, 1, 1, 1, 3 bits of the fourth octet are subnetting bits. So that would be our new subnet mask. Let's do one more. And then we'll take a break. You release the following network, 145.10/19. Don't let that throw you. Just remember, the first 19 bits are untouchable. That's how you need to look at that. From the single network, you need to create 58 subnets. What will be your new subnet mask? Time's up. There's your new subnet mask. So how did you come up with that? How did we come up with that? So here's how I would do this. Well, 58 subnets. Let's see. 2 to the power of 1 is 2, 4, 8, 16, 32, almost there, 64. So I need to steal 6 bits. That'll give me up to 64 subnets. So I need to add 6 bits to this. So 19 plus 6 is going to be 25, or a /25. So that means here's my 24, and 128 gives me my 25th bit. So that's how you got that.